In this video, we will discuss the other part or all the rest of the questions that can come in that exam. And one of them is derivative of the vector valued function r of t. So if you're given a function r of t, 3 cos t, comma 3 sin t, comma 2 t to the power 3 over 2, how to find out its derivative is it's very simple. It's just the it's just following the same rules of derivatives. You have to differentiate each part separately. So the derivative of cos t is minus sin t, so that gives us minus 3 sin t. The derivative of sin t is cos t, so that gives us 3 cos t. And the derivative of 3 to the power 2 would be the power comes in front and you subtract 1 from the power. So 3 over 2 minus 1. And when you simplify this, that gives you 3 sin t comma cos t. This 2 will cancel this 2. So you are left with 3. And if you take the LCM of this one, that gives you 3 minus 1 divided by 2, which gives you 2 by 2, and that gives you 1. So that gives you 3. Gives you minus 1 gives you half. Sorry. So 3 minus 2 divided by 2 gives you half. So this is your derivative. You can find out the derivatives of all the vector valued function in this format. Now, since this is being used to find out the arc length, so the actual problem would be to find the arc length, which is denoted by L, of vector valued function. So you need to find out the arc length. You will write down the formula. What is the formula? And this is when the t is between 0 and 3. So you need to find out the arc length of this vector valued function between t between 0 and 3. So for that, the formula is v is equals to from 0 to 3 and dr by dt magnitude dt, or you can write this as from 0 t r prime of dt. So for the formula, we need the magnitude of r prime of t. That's why I left r prime. So we have to take the square of the first entry, the second entry, and the third entry, and then we have to add them up and take its square root. So if we do that, this gives us 9 sine square t, this gives us 9 cos square t, and this gives us 9, and half into 2 gives us a t. So if we take 9 common from here, this is sine square t plus cos square t, and the 9t, we know that sine square t plus cos square t is equals to 1. So this gives us 9 plus 9t. And if we take out 9, so 9 into 1 plus t. And if we take out 9, it gives us 1 plus t. So our r prime of t mod is this one. Now we can replace the r prime magnitude in the formula, and now you can use any method. So first you can use the substitution. If you don't want to use the substitution method, what you can do is you can write this as 1 plus t to the power 1 over 2 dt. And one of the rule is that if you have a function over here and its derivative is over there, so if you have 1 plus t is a function and the derivative of this function is what? It's 1. dt. We already have that thing. So it means you have to add 1 to the power and you have to divide the same number by the same number. That will give you the integration. So that is 3. Its derivative is here, so we can use that as 1 plus t, and you add 1 to the power and you divide by the same number. And the limits should apply at the end. So this would give us 3, 1 plus t. So 1.5 gives you 3 over 2, and that is 3 over 2. So the 3 will cancel this 3 and the 2 goes up. So you have 2 and you have 1 plus t, and the limits goes from 1 to 3, from 1 to 3. So you can substitute the limits. Once you put 3, so 1 plus 3 minus, then you put 0, 1 plus 0. And you can see that is 4. 4 minus 1 gives you 3, and 3 times 2 gives you 6. So you are wait a second, we did something. Okay, this is 3 over 2. So this is 3 over 2 and this is 3 over 2, and 4 power, this is 4 to the power 3 over 2. So this means that is 2 into 2 and then 3 over 2. So this will cancel this one, and this is 1. So that is actually how much? 2 times 2 times 2 is 8. 8 minus 1 is 7, and 7 into 2 is 14. So your answer is 14. The next part would be to find out the unit tangent vector t, the unit normal vector n, the binormal vector b, and the curvature kappa k, small k. And the formula for these are the derivative of the unit vector valued function r, and divided by its magnitude is the formula for the tangent vector. For the normal, it's the derivative of the tangent divided by its magnitude. The binormal is the cross product of the unit tangent vector and unit normal vector. And the curvature can be found by 2 different formulas. So you can also find out different formulas for these. So that is t prime divided by the magnitude of r prime, or you can say the magnitude of r prime cross r double prime divided by r prime whole magnitude cube. So you can use either of these formulas. Instead of using this one, you can use the derivative. You can take the derivative of this one and use it. So it's up to you. So you are given a vector valued function r of t, and they're asking you to find out all these. So if you want to find out r unit tangent vector, you need r prime and its magnitude. So let's find out r prime would be then the derivative of sine is cos t, the derivative of cos is minus sine t, and the derivative of sine again is cos t. Now we found out the derivative. Now we need to find out the derivative, the magnitude of it. So the magnitude is the squaring of each component and add them up. So cos t square plus square root 2 sine t square and plus cos t square. So that gives us cos square t plus 2 sine square t plus cos square t. So that is actually 2 cos square t plus 2 sine square t square root, and if we take 2 common, that is cos square t plus sine square t, and we know that this one is 1, so the answer is square root 2. So r prime is this one. So now substituting the values for r prime of t, which was cos t minus square root 2 sine t and cos t divided by square root 2. So you can write this as, you can just divide each of them with a square root 2. or you can just leave it like that. So that gives you, this will cancel this one, 1 over square root 2 cos of t minus sine of t, and 1 over square root 2 cos of t. So that is over t, the unit tangent vector. Now to find out the unit normal vector, we have to find out its derivative. So let's find out the derivative, or you can use it like this, or you can use it like this. So prime of t would be to take the derivative of each part. So this one would be minus 1 over square root 2 sine t, minus sine is cos t, sine is cos t with a minus, and that is minus 1 over square root 2 sine t. What else do we need is to find out its magnitude now. So again, for the magnitude, you have to just find out the squares of each component and add them up. So the square of minus 1 over square root 2 sine t, we will take the square of this one, minus cos t, take the square of this one, and minus 1 square root 2 sine t whole square. We can see that this would gives us sine square t, and the square root of 2 taking its square would give us 2. That would be plus cos square t, and that would be again 1 over 2 sine square t. And half and a half, when you add them, that gives you 1. So that what gives us sine square t plus cos square t, and we know that sine square t plus cos square t is 1, and the square root of 1 is 1. So our magnitude of t prime is 1. So you can simply now put the value of t prime and its magnitude. So the magnitude is since 1, so you divide anything by 1 would be the exact same value. So this would give us minus 1 over 2 sine t minus cos t, and minus 1 over square root 2 sine t. Now the next one is the binormal. So what you have to do is to multiply, so it's to take the cross product of of t and n. So the t value, you have to write down the t value, what obviously we can write from here is 1 over 2 cos t, that would be minus sine, and that would be 1 over square root 2 cos t. So now what you have to do is just find out their cross product. So B is t cross n, so that is I, j, and k. T is 1 over 2 cos t, with a square root, and minus sine t, and 1 over square root 2 cos t, and n is minus 1 over square root 2 sine t minus cos t, and minus 1 over square root 2 sine t. Now what you have to do is just find out the determinant. So we take this portion, ignoring this row and this column. So this into this gives us plus 1 over square root 2 sine square, and then minus, and this gives us minus something, so that minus minus becomes plus, and that would give you 1 over square root 2 cos square t. So I is calculated then with a minus, and then j. Now we ignore this row column and this row and multiply these two minus these two. So if we multiply this into this, that gives us minus 1 over 2. Square root 2 into square root 2 gives us 2, and that would be sine t cos t, and then minus, but there is another one more minus, so multiply by them gives us a positive, and this gives us 1 over square root 2, and this gives us sine t and cos t. And you can see that they are plus minus, so they will cancel each other at the end. And the last one is k. So we ignore this one and multiply these four components. So this into this gives us minus 1 over square root 2 cos square t, and minus minus plus into minus, so minus 1 over square root 2 sine square t. So now if we look at this one, 1 over square root 2 is common, so we take 1 over square root 2 common. Sine square t plus cos square t is remaining. They cancel each other, so that gives us 0, j, and plus. Then here is minus 1 over square root 2. So if we take minus common and then 1 over square root 2 common, we are left with cos square t plus sine square t. And we know this is equals to 1 and this is equals to 1. So our b is now 1 over square root 2 I minus 0j minus 1 over square root 2k. So this is our b. And finally, the kappa is, we already know from the previous calculation that t prime magnitude is 1 and the r prime magnitude that we found out was square root 2. So that is your answer. Or you can multiply this and divide by square root. Say if I multiply and divide by square root 2, this you can write the square root 2 into square root 2 divided by 2 into square root 2. So that cancels out. Some answers would be of this type. So this is the answer and this is the answer. They're both the same, but it depends on which answer was required. The next topic is finding velocity, speed, and acceleration. So velocity is the derivative of the vector valued function r. Speed is taking its magnitude, and acceleration is the derivative of the velocity or the double derivative of the vector valued function. So if you are given a particle whose motion is defined by this vector valued function, then they're asking you to find out the velocity, speed, and acceleration at time t is equals to 1. So the first thing we need to know is our velocity is the derivative of the vector valued function, so we need to find out its derivative. And the derivative, it means that you have to find out the derivative of each part or each component separately. So the derivative of pi t would be pi minus the derivative of sine is cos pi t, and then you have to find out the derivative of the inside one. So the inside derivative would be pi, so you multiply that pi over here and you have an I over here. Now the derivative of 1 is 0 minus the derivative of cos is minus sine, so that minus minus becomes plus. So I would say plus sine pi t, and then you find out again the derivative of the inside one, and that pi t derivative is pi, so we just multiply that over here, and that is our j. So our velocity in general is given in this formula, and they're asking you to find out the velocity when t is equals to 1. So just replace t with 1 and you would find out the velocity. So that is t times 1 times pi is pi minus plus pi sine when t is 1, that gives us a pi, and then you can see that that is pi minus cos of pi is minus 1, you can use your calculators, and sine of pi is 0. So you can see that the velocity at point 1 is, so that is minus into minus plus, so pi plus pi gives you 2 pi I and plus 0 j. So you don't need to write down 0 j, but if you write it down, that's all right. Now to find out the acceleration, we have that acceleration is equals to the derivative of v. So we can find out its derivative. the derivative of pi is 0 minus pi times the derivative of cos is minus sine pi, and the derivative of the inside is pi. So we have this thing, and now the derivative of sine is cos pi t, and then you multiply, you find out the derivative of the inside, which is pi. So you simplify this, pi into pi and minus into minus gives you pi square sine pi t, and then pi into pi gives you pi square cos pi t, and this is I with I, and this is j. So this is your acceleration. Now what we have to do is to find out the value acceleration at t is equals to 1. So you just replace t with 1. So when t is 1, this gives us pi, and plus pi square cos of t is 1, then it gives us pi, and sine pi again is 0, so that is 0i, and cos pi gives us minus 1, so you can that minus pi square j. So our acceleration at 1 is 0i minus pi square j, or you can just write down minus pi square j. And the final value is speed, which is the magnitude of velocity, and we have the velocity, so just find out its magnitude would be the square root of the square of each component and add them up. So that would give you, you can use this, the formula a minus b whole square. So that would be pi square plus pi square cos square pi t minus 2 times first and second. So first is pi, second is pi cos pi t, and then plus this one, which is pi square sine square pi t. So we can see that something is common. Somewhere something is common. So if I take pi square from here and from here, we can get this one, which is equals to 1, and this is minus 2 pi square cos square pi t. All right. So this gives us pi square plus this gives us 1. So pi square minus 2 pi square cos pi t. And this is our speed. You can find out the speed at t is equals to 1. So if you want, you can add them up. So you can write this down, that pi square minus 2 pi square cos pi t. You can further simplify it, but if you don't want to simplify, just put the value of t is equals to 1. So speed when t is equals to 1 is 2 pi square minus 2 pi square and cos of pi when t is 1. And we know that cos of pi is minus 1. So minus and minus becomes plus. So this gives us 4 pi square square root, and that gives us 2 pi as the speed. Why don't we write down the negative? Because speed cannot be negative. And the final set of examples is to find out the tangential component of acceleration, normal component of acceleration, and the curvature kappa. So the AT normal tangential component of acceleration is, the formula is r prime dot r double prime divided by its magnitude of the r prime. Then the normal is r prime cross r double prime divided by the r prime magnitude, and kappa is the r prime cross r double prime magnitude divided by r prime cube. So it's just taking this cube of this one, and you get the answer. So the first one is tangential component of acceleration. We need r prime. So first find out r prime. That would be minus a sine t. That will be a cos t, and that gives us only b. We need the double prime. So the double prime would be minus a cos t, that is minus a sine t, because the derivative of cos is sine, and that is 0, minus sine, not sine. So now we need to find out this dot product r prime dot r double prime is actually you multiply component wise and add them. So this component would multiply to this one. So minus a sine t into minus a cos t plus this component will multiply to this one. So a cos t and minus a sine t, and plus the last two components b into 0. And we can see that does give us a square sine t cos t, minus minus becomes plus, and then minus plus gives us minus a square sine t cos t plus 0, and these cancels out each other. So you're left are double prime to be 0. So now you don't need to calculate this one, but since we will require that for the other formula, so you should find that out. So this one is 0. We need to calculate now the magnitude of r prime. So the magnitude of r prime would be the square of each component and add them up. Minus a sine t square plus a cos t square and plus b square. So that gives you a square sine square t plus a square cos square t plus b square. If we take a common, a square common, that is sine square t plus cos square t plus b square. And now we know that a square plus sine square t plus cos square t is 1. So this gives us the magnitude of r prime is a square root of a square plus b square. So the tangential component is r prime dot r double prime, r prime magnitude. This one is 0 and this one is square root a square plus b square. It means the tangential component is 0. Now to find out the normal component, we need the cross product of r prime and r double prime. So we have write them already in that form, and we need to find out the determinant. So 0 times anything is 0, minus, and then minus minus becomes plus. So that would be ab sine t, then minus j. We leave this thing, this into this is 0, and minus plus ab cos t, and then for k, that is minus plus a square sine square t, and minus, and this minus again plus a square cos square t. So that gives us ab sine ti minus ab cos tj, and minus, if we take a square common from this one, this would gives us, so if we take a square common, sine square t plus cos square t is 1, and that gives us then a square k. So this is the cross product, and now we have to find out the magnitude of this cross product. So to find out the magnitude, we take the square of each component and add them up. So that gives us a square b square sine square t plus a square b square cos square t plus a4, and again if we take a square b square common, we are given here, we are left with this one. This is equals to 1, so we have a square b square plus a4, and if I take a square common, so that would be here b square plus a square square root, and if we take a square out of square root, so we have a square plus b square. It doesn't matter, you write down b square plus a square or a square plus b square. So the magnitude is a into square root of a square plus b square. So now we substitute the values in the formula, and that one we already knew was a square plus b square, so they cancel each out, and we have the tangential component is to be a. For kappa, we already know that the a cross b is, the r1 r prime cross r double prime magnitude is this one, and the r prime is this one, so that is a square plus b square square root power 3. So this we can write as a square plus b square 1 over 2, and that would be a square plus b square 3 over 2. So if we take this down, a square plus b square, and that would be a square plus b square minus 1 over 2. When bases are same, you add the powers. And so if you add 3 over 2 minus 1 over 2, that gives you 2 over 2, and that cancel out gives you 1. So the kappa would be a over a square plus b square power 1. So you just write that down. So I hope you understand all these formulas, and if you are given any type of problems to solve, to find these out, you would be able to solve them. Thank you very much.